to the Amazon Web Services Cloud.
I'm Julian. I'm a technical evangelist with AWS, and I'm based in the Paris office. And sorry, I don't really speak German. I could try, but I'm afraid you wouldn't understand a word of what I'm saying, and that's not quite the point. So thank you so much for visiting us in the Loft. It's a pleasure to see you guys. And today, it's a fun session, I hope. I'm going to walk you through the different ways of deploying code and applications to AWS. Okay, and so hopefully it will last 60 minutes, and I won't be too long. But if you have questions, please ask your questions. I'll be around after the session. I'm also here tomorrow, so we have plenty of time after the session as well to talk and answer all your questions. Okay. So before we start, just to make sure and understand who's in the room, who has never used AWS before? All right, welcome guys. So this is the session for you. Who has used EC2, started virtual machines? All right, a couple of people. Yeah, a few more. Elastic Beanstalk? All right, good. ECS? Docker? No? All right, and Lambda? More people have tried Lambda than ECS. That's interesting. Okay. All right, so you're in the right session, okay? We're going to go through all four, do a lot of demos, and hopefully answer many questions, okay? So let's get started. So we have 4 ways of deploying code, 4 different technologies to do this on AWS. So the first one is EC2, deploying virtual machines. Second one is Elastic Beanstalk. It's a PaaS, platform as a service product, where you will only deploy your app and not manage the underlying infrastructure. We have ECS, which allows you to manage Docker clusters. And last but definitely not least, you have Lambda, which is a new way of deploying code by deploying only functions, stateless functions. Okay, so we're going to study all 4. And we have a blog dedicated to compute technologies. So it's updated all the time, so I strongly advise that you keep an eye on this to know about the latest features, latest examples, etc. It's a really, really good way of staying in touch. So let's start, and we'll go in chronological order. I think that makes sense to see the progression of computing. So the first one, I'm sure you've at least heard the name. it's EC2, okay? EC2 is the virtual machine technology of the AWS cloud. It was launched in 2006. So, it's been there for a while. It's been there for 10 years now. Extremely solid. And it's really one of the foundations of the AWS cloud. And this is really a lower level service, right? If you want to call that infrastructure as a service, well, why not, okay? So, basically, what you're going to do is you're going to select a machine image. We call that an AMI, Amazon Machine Image. That could be a Linux image, a Windows image, your own image that you created, all kinds of different images. You're going to select an instance size. Okay, and the size will drive the CPU power, the amount of memory, and a few other things, network I/O, etc. Okay. And you're going to start your virtual machine, right? And that's it, really. It's a very simple service. And once the server is up, when the virtual machine is running, then you can connect to it and manage it like you would manage a normal server, okay? So nothing extraordinary, pretty basic. And the good thing about EC2 is that, of course, you get the virtual machines, but you get a whole different set of services that work with EC2. So you get, for example, load balancing, you get monitoring, you get auto scaling, you get network storage, EBS, etc., etc. Okay, So it's not just, okay, let's start a virtual machine in the middle of nowhere and then, what can I really do with it? Here, you start virtual machines, you can load balance them, you can scale them, you can monitor them, etc., etc., etc. Okay, so it's really a very, it's a basic service, it's infrastructure as a service, but it's really powerful, and a lot of customers are using this to build their platforms. Okay, how much does it cost? Well, it's quite simple too. You pay by the hour, depending on the instance size. So obviously, the more powerful the instance is, the more expensive it is. And that's it, okay? So you start an instance, and as soon as it starts, you start to pay by the hour, okay? It doesn't matter if the instance is actually used or not, right? Starting it means you have to pay for it, okay? We'll get back to that, because that's a huge difference with Lambda that I'm gonna cover later on. In some cases, let's say you started an instance that you took from the AWS marketplace, which is where software vendors will package and offer their software for you guys to use. And some of this software is free, some of it you have to pay for it, right? So sometimes there's the instance price, and then there's also an hourly fee that the vendor will add on top of the VM fee, okay? So you have to be careful there. So when should you use, in my opinion, EC2? Well, you should use it when you really need full power, full administrative power on your infrastructure, okay? When you want to be fully in charge of the server, managing it completely, then fine, EC2 is the way to go, okay? But remember, with great powers come great responsibility. So if you decide to do this, you really have to manage your instance. You're in charge of security, you're in charge of patching, you're in charge of backups, etc., etc. Okay? So keep that in mind, because again, this will be a big difference with the other technologies. There are two other things I want to mention, because they allow massive savings. It's reserved instances and spot instances. Reserved instances is basically a way of saying, well, I've got these 25, 30, 50 instances, and yes, they really run 24/7, right? I'm never stopping them. They're really needed in my infrastructure. Maybe they're database servers, something that you don't want to power off at night. Then you can contact the AWS team, and you can sign this reserved instance deal, where by prepaying a certain amount over 1 year or 3 years, you get a large discount. Okay, that can go from, let's say, 20% to probably 60 and 65%. Okay, just by saying, okay, I'm committing to use this for 1 year, let's say, or 2 or 3 years, and I'm prepaying a certain amount. So immediately you save up to 60%. So that's pretty cool if you really need those instances to be up all the time. And spot instances are completely different. There's a marketplace for unused EC2 capacity, right? At any given time, we have unused EC2 capacity. And you can buy this extra capacity that no one uses with a bidding mechanism, right? So it's like bidding. So there's a market price, and you bid for a certain instance size. If your price is above the bidding price, then you get your instance, okay? And you can get the instances at up to 90% less, right? So that's divided by 10, okay? So it's a huge discount. You can get the same instance size 10 times cheaper. So what's the catch? Okay, the catch, right? Because there is one, but I'm telling you, so it's not really a catch. The catch is that if the market price exceeds the price you're paying for the instance, then you're going to lose the instance in 2 minutes. You get a notification, and 2 minutes later, the instance is gone. Okay? So a couple of consequences. Do not run all your infrastructure with spot instances, right? Do not put anything that should be long-lasting in spot instances. Database servers come to mind, okay? Web servers, fine. Stateless stuff, fine. Database servers going down in 2 minutes, No, okay? And the last consequence is, of course, if you bid a fraction of a cent above market price, there's more risk than you're going to lose the instances than if you bid at, let's say, 15% or 20% above market price. Okay, so you can manage the risk versus the savings. Okay, you can look it up on our website. You have some examples there, but bottom line, EC2 is great. You get a proper server. You can manage it completely, and we're going to start one in 5 seconds. But you have work to do, you have security to do, you have backups to take care of, etc., etc. And you pay by the hour, right? So hourly price times 24 times 365, it always comes up to a significant amount, right? So if you really need the instances to be up all the time, try to study reserved instances or try to work with spot instances, and you will save a ton of money, right? And we want you to save money, believe it or not. So how would you start an EC2 instance? Well, of course, you could go in the console and click everywhere, okay? But serious people like you, they want scripts, right? They want to do this automatically. So this is how you would do it with the AWS CLI. Okay, so AWS is the actual tool. EC2 is the name of the service. Run instances, to start a new instance. I'm also mentioning the image ID, right? The AMI. So in this case, it's our Amazon Linux distribution. The instance type, T2 micro. That's really small. Okay. Really inexpensive. An SSH key because I want to SSH to that server. A security group ID. Security groups are it's the managed firewall feature of AWS. So this is where you're opening ports and allowing access to an instance. And the region where I want to start it. So EU West, which is the Irish region. Okay, so let's try to do this. So I did prepare a little bit because you don't want to see me typing. Okay, so that's the exact same command that you saw, right? Sorry?
Is that the AWS tool into which you're typing?
No, that's so. This is here. I'm working locally on my Mac. Okay, I'm doing everything locally from my Mac and sending commands to AWS. Okay, so it started and it sent me way more information than I really wanted, but that's how it works. Okay, so you can see. Whoops, you can see that the instance has been started. And I see a lot of information on, what subnet it has been started in and the IP address, etc. Okay, so now if I'm looking at the AWS console, I should see, yeah, it's in there. Okay, it's this one actually. As you can see, it's initializing here. Okay, so that's the console if you've never seen it before. This is where I'm seeing all my EC2 instances. Right, for the Irish region, okay? If I want to start stuff somewhere else, I could choose any of those, right? Sydney, Seoul, Frankfurt, select that, and I would work with that part of our infrastructure, okay? Okay, so it started. It has a public DNS name, so why don't we try to connect? Hopefully it's ready. Yes, all right. Nothing spectacular, SSH. But okay, that's my server, right? And it would be exactly the same way if you started a Windows server. Of course, you would not SSH. You would probably RDP into the instance, but it's a similar thing, okay? If you want to build your own AMI with your favorite Debian or whatever distribution, you can do that too. That's how you do it, right? So now, let's say I need a server in Frankfurt, right? Sorry, we don't have Munich yet. Okay, so all I need to do is to change the region. And that doesn't work because my security group does not exist in that region. Okay, so I don't have the time to do it, but this is what you would do, okay? You would just you would just change the region, put the right security group reference for that region, and you would start it, okay? And from the console, you would just, like I said, probably I have some stuff running in the US. Let's take a look. Yep. And I could do things manually as well. Just click the big blue button, select my AMI, select an instance size, give some network preferences, etc., and I would launch it. Okay? But again, clicking in the console is nice when you want to experiment and learn, but for production, you want to script and automate, obviously. Okay? Okay, so this is really the most important command for EC2. That's the one that starts instances. There are quite a few more, actually. EC2 has 211 APIs, so it's very granular, so don't worry, you don't have to learn the 211. But there's quite a few, right? Starting instances, stopping instances, managing security groups, etc., etc., etc. Okay, so it's a pretty rich API here. Okay, so that's how you do EC2. Right, fairly simple, full power, full administrative power on the instance, but you have to work with it, right? So now let's look at the second product, which is Elastic Beanstalk. And as you will see, it's quite different. So it was launched 5 years ago, and EC2 was infrastructure as a service, right? You started infrastructure and you had to manage it. Elastic Beanstalk is platform as a service, because in this case, we will provide a full platform for you to work with. So we support a number of platforms, PHP, Java, .NET, etc. I will show you the full list on the next slide. It's quite long. And this is really a product for developers, okay? Because typically developers do not want to manage infrastructure, right? You don't want to worry about starting instances and managing subnets and firewall rules and etc. You just want your PHP environment or your Java environment or your Ruby environment where you can drop your code and test it and hack it and just work, do some useful work instead of managing infrastructure. Okay, so there's a specific command line for Elastic Beanstalk, which I'm going to use, called EB, right? And it's really easy. It doesn't have a lot of commands. It's, as you will see, you create environments and you deploy your code, and it's really, really easy to learn. This is you have built-in monitoring, built-in networking, etc. And again, I think this is the simplest way. And this should be the default way of deploying code. Usually people rush to EC2, because they want that server, right? Give me a server. Okay, here it is. But then they have to manage, they have to install their PHP environment or whatever, and they have to take care of everything. And that is a problem. Okay? So Elastic Beanstalk will provide all that stuff for you, and all you have to do is deploy your code. Okay? So let's look at the platforms. So that's the full list, okay? And it's constantly updated with the latest revisions. So you can deploy Docker containers, you can deploy Java, Tomcat, Golang, Python, Ruby, PHP, Node.js, with all different versions, right? And it keeps getting updated. So when there's a new PHP version, PHP 7 is there, and whenever 7.1, 7.2, 7.3 show up, they will be added, right? So lots of different platforms. So let's dive a little deeper. So when I'm saying it's platform as a service, right, it's because all you have to provide is that green thing, your code, okay? Everything else will be delivered by Elastic Beanstalk, okay? So contrast this with using EC2. if you use EC2, you have to select an operating system, right? And you have to patch it and take care of it in the long run. You need to have an application server, so you need to install your Nginx or Tomcat or whatever you need. You need your language environment, so your PHP distribution, your JDK, your Ruby platform, etc., etc. And God knows there's a lot of work involved in maintaining that in the long run, right? Security problems, patches, etc., etc. Okay, so here, all the gray stuff is what the Beanstalk environment is going to build automatically for you. Okay, just add your code. So let's do a small demo. So we don't have much time, so I'm going to keep it really simple. So what I'm going to do, I'm going to create a very simple Rails application. It's a blog application because I think the world needs another blog application, especially mine. You know, you can never have too many blogs. I'm going to create that application. I'm going to deploy it to Beanstalk and change a page somewhere and redeploy it. Okay? So to save some time, I did prepare the demo, but I'm going to show you the steps. So the first important thing is that you need to use Git because Beanstalk is going to deploy from your committed code in Git. Okay, so you can have multiple branches, of course, etc. But Beanstalk is going to deploy from the committed code. Okay, there's an option to deploy from the staged code, but by default, we deploy from committed code. So I'm creating a new app, a new Rails app, which I'm calling blog, right? I'm adding all the stuff that Rails created to Git, and that's my first version. Okay, so far, so good. Then it's a blog, right? So a blog needs posts. So I need to add a post resource to Rails. Okay, so a post will have a title, which is a string, and a body, which is text. Okay, so I'm asking Rails to generate all the templates, all the code for this post resource. Then I'm applying this to the DB, adding everything to Git, right? And at this stage, you know, I should be able to start locally my Rails app and open it. So let's try that. Make sure that it actually works. Okay, so that's everything that Rails created with those few commands. Okay? So let's try to start this. Okay. And let's open it locally. Okay, so Rails is running. And yeah, okay. So that's my code, okay, locally. So let's try it. Yeah. Okay, so this seems to work, right? I'm on my way to becoming a billionaire with this application. But this is all local, right? So now I want to bring that code to Beanstalk, okay? How do I do this? So the first EB command that you need to learn is EB init, where you're going to create a new Elastic Beanstalk application. Okay, the two parameters that you need to give here are what platform you're going to use and in what region do you want to start this new application. So in my case, I'm going to use Ruby. That's a shortcut name pointing to the latest version. But if you needed Ruby 2.0, patch level, whatever, you could also use that, okay? That full list that I showed you before, that's where you would use those names. And I'm starting that app in EU West 1, okay? And the only thing that it does really is It doesn't deploy any code. It just creates that application in Elastic Beanstalk. Okay. So let's run this command. Okay, so it was very fast, so it didn't do much, right? Obviously. Maybe if we take a look at the Beanstalk console, we can see some more stuff. Okay, that's the Beanstalk console, and I see, okay, there's a blog application that is created, but no code yet. So this is just initializing, say, hey, I'm about to create Ruby stuff in EU West 1. Now what? So I need to ignore the config files for Beanstalk. But the really important thing is this, is now I want to create I want to create an environment. Okay? So the difference between application and environment is the application is the overall thing, right? It's Ruby. It's a Ruby app running in EU West 1, and I can create multiple environments. And usually that's what people do. They create one from development, maybe one environment for each developer, right? That's because, as you can see, it's really easy to do. And then they will have environment for pre-production and production, et cetera, et cetera. So how do you create that? So here I'm assuming I want a simple development environment. I just want a single instance. I don't need auto-scaling. I don't need load balancing. I don't need anything fancy, okay? So I'm going to call EB create block dev, which is the name of the environment, single, which says this is a single instance, right? Just start me just one server, an SSH key to connect to that instance if I need to, and this is Rails stuff, but Rails apps need a secret token to encrypt cookies. So you don't want to know, okay? But this just shows you that you can also pass environment variables to your deployments, okay? So let's do this. See what happens. So if you remember that slide I showed you with the green code and everything else, okay, that takes care of the everything else. All right? So yeah, lots of details here. So what do we learn? So EU West 1, good. Platform is Amazon Linux running Ruby 2.3. Blah, 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 blah. Okay? And what it's going to do as well is look in that directory where I run the command, get the committed code from the Git repo, zip it, copy it to S3 or object storage, and deploy that code. Okay, so that's what you see here, deployed version, right? That's the internal version name for that app. Okay, and as you can see, it's creating all the infrastructure resources that I need. So it's creating a security group, right, to manage ports. It's creating an IP address, and it's going to create the instance, etc., etc. Okay. So how does that work, actually? Right? Let's look under the hood while it's doing this. Has anybody heard of CloudFormation? 1, 2, yeah, come on. 3, yeah, 4. All right. So CloudFormation is here, and it's infrastructure as code technology, where you describe the infrastructure that you want to build in a template. Yep. That's either written in JSON or YAML, right? We support YAML now. And in this template, in this case, we would create an EC2 instance, a security group, an IP address, we would install the Ruby environment, blah, 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 blah. Okay? And Elastic Beanstalk is all obviously building those templates automatically. And this is what you see here. Okay? So if I'm zooming out a little bit, we should, so don't worry about here, right? This is just the template. It's generated automatically by Beanstalk, so it is pretty difficult to read. Okay? But this is the magic of combining platform as a service with infrastructure as code, right? One command, one click, and you start all that stuff automatically. And if I want a second environment, block dev2, I can just create it immediately. And if I need 10, I can create 10 with the same command, right? Just changing the environment name, because it's all automated in the background, okay? If I'm looking at the events here, well, actually it's done, so we can take a look, right? So I can see all the events, all the entities that Beanstalk has created. Okay, so let's go back to my block dev here. Okay. Right, so in the Beanstalk console, you can see a summary of those events. Okay, and I see that the EC2 instance is starting. So if I'm going back to the EC2 console, I should see something. But I need to go back to Ireland, of course. Here it is. Okay, block dev. Okay. So you see, it's always, I mean, how these products relate to one another. Yes, at the end of the day, you're always creating EC2 instances, but in a much more automated and much easier way, if you ask me. Okay. So, is this ready yet? I want to see that code running. If not, we will just move on and I'll get back to that in a minute. Okay, so let's just wait for the environment to start. It takes 5-6 minutes. And then we'll go back to that and I'll show you how to deploy code. Okay. So let's move on to the third way of deploying code, ECS, EC2 Container Service. So any Docker fans in the audience? Just one? Oh, wow. Usually it's like 60 hands. Okay, all right. So ECS is not just about running Docker on AWS. It's about running Docker clusters in AWS. So let me explain the difference. It's very easy to start Docker on your own machine and start your containers, and everybody does that today. But when you move to production and you need to run hundreds of containers on a large number of servers, that's where the real problems start, right? Because what happens if one of your servers goes down and all the containers running in there die? You have to restart them in a way, hopefully not manually. So at a certain scale, you need to have a piece of software that manages your clusters, takes care of scheduling, takes care of high availability, etc., etc. And this is what ECS does. Okay, this is what ECS does. So it manages a cluster of EC2 hosts with Docker installed, and where you're going to start your containers, not your instances. Okay, we have another product called ECR. Which is a Docker registry hosted in AWS, very secure, highly available, etc., where you can put your Docker images and deploy them real close to your infrastructure. Right. You can also use the Docker Hub, but unfortunately, the availability of the Docker Hub is not awesome. And you don't want your deployments to be stopped because the Docker Hub is down. So ECR is a good alternative. So here as well, we have a friendly CLI, which is called ECS CLI. We also use CloudFormation to build everything. And this is what it looks like. Okay, so we have a number of instances. Here we have 3, right? So they are EC2 instances with Docker installed. We provide a specific AMI for this, but you could use also your own AMI. And in Docker, you're going to deploy your containers, right? So these are really standard EC2 instances. The only addition is the ECS agent, which is a small piece of software that is going to communicate with the ECS backend. And so basically, when you're going to say, hey, please start 5 copies of container A, the backend is going to communicate with the agents to find where it can start this container, what instance has enough resources to do it, etc., etc. Okay? If an instance dies, or if some containers die, then the backend will start a new instance if needed, restart the right number of containers, etc., etc. Right? I can't go into too many details because I don't have time today. I have a dedicated session on Docker tomorrow, I believe, at the same time. So if you want to learn everything about Docker, come back tomorrow. Okay, so that's the basic idea. And again, this is what the ECS CLI calls are going to build. Okay? So before we do the ECS demo, let's go back to Beanstalk for a second. It's probably ready. Yes. So my environment is green, which is good. And I've got a URL here. So let's try this. Of course, I need the post resource here. Yep. So looks the same. Okay, same app. Okay, same app. How did I do this? One EB init command, one create environment command. That's it. Now, let's change something here, real quick. Okay, so if I'm reloading the local version, okay, I see, okay, locally, obviously, I've got the change. Now, I need to commit this change. Okay. Okay, so now it's committed. And if I'm calling EB deploy, okay, I'm zipping the committed version, copying to S3, deploying it on my instance. Okay? And if I go back to this, where is it? It's here. Okay, so I'm updating my environment. Right? Deploying new version to instance. And that should be reasonably fast. So if I'm reloading, yeah, that's the AWS version here. All right?
You have lost your first block entry.
Yes, because I'm using SQLite as my database. And it's redeployed all the time. Okay, so the proper way of doing this is to use a proper database, like Postgres, for example. And Elastic Beanstalk allows you to interface with RDS, the relational database service, which manages, which is the managed service for MariaDB, MySQL, Postgres, Oracle, SQL Server, Aurora, which is our in-house MySQL. Okay, I've got a deep dive on RDS. Sometime 2 weeks or something. I have the reference at the end of my presentation. Okay, so if you use the real proper database, of course you would keep all the state. Okay, but it's 4 services in 1 hour, and it's a challenge. Okay, so this is how you would do Elastic Beanstalk, and you could do much more. You can get the logs for your application. Is it Wi-Fi fooling with me? EBSSH. Okay. So you can connect the instance if you want to, but you should not do it, right? That's what this message says. This is a managed instance. So any change that you perform here is going to be overwritten by the automatic deployments, right? So it's only maybe for debugging that you want to do that, okay? Let me try the logs again. Come on, I want the logs. Should not be long like this. All right, they will come eventually. So, okay. Oh, yeah, did they show up? No, not yet. All right, okay. Forget it. I think my Wi-Fi is a little slow today. Oh, no, here they are. Okay. So I can get all my Ruby logs or my app logs, etc., etc. Okay, and I can do this without logging to the instance. That's my point. Okay. So all the error logs are available. So that's for Beanstalk. So now let's look at ECS. So the first thing I'm going to do is I'm going to configure a new cluster, which is similar to creating an application in Beanstalk, right? Just declaring it. And then I'm going to start the cluster. So this takes a few minutes, so let me do it quickly, and I can explain while it runs. Okay, so configuration here is just, okay, hey, I want an ECS cluster, I want to call it my cluster. Doesn't do much. And this is the really important one. So this one is going to create, and notice I'm using the ECS CLI command, okay, which is specific to ECS. So I'm creating a new cluster with the up command. I'm giving an SSH key because I want to connect to those instances. Capability IAM is just to allow ECS to create IAM roles, and IAM is Identity and Authentication Management, which is the permission framework for AWS. What's the size of the cluster when it's one node? So it's not a big cluster, but we'll scale it later on. And instance type is T2 micro. I don't need to have large nodes, okay? So again, as you can see here, it's not even hiding the fact that it's using CloudFormation. I'm going to create my cluster, and I should see that here. Yep, see? Same story. Template, right? Automation at work, okay? And I can see...
It's still within the EC2 container service.
What do you mean?
We're now building a container within Docker in the EC2.
No, we're building a cluster, right, of one instance. And this instance, is an EC2 instance running Docker and the ECS agent, which will be driven by the ECS backend, okay? So it takes a few minutes, again, but I like live demos. So let me explain what we're going to do next while this builds. So once the cluster is up, okay, we're going to deploy an application to it. So it's a small PHP application, and I'm going to deploy it using a compose file. So if you're familiar with Docker, you know that you can write compose files, Docker compose files, with certain properties, environment variables, volumes, storage volumes, linking between containers, etc., etc. Okay, so I've got that small file written. I'm going to show it to you. I'm going to deploy it, and once this has run, that's it. My Docker app, right? My PHP app, which is hosted in ECR, by the way, is going to be deployed on that cluster. Okay, one single command. Okay. And every time I'm fixing stuff on that image and I want to redeploy it, I can just run service up again and deploy the new version. Okay. Then I'm going to scale the cluster to 3 nodes, 3 instances, right? With the scale command. And I'm going to scale the service as well, because now I have 3 nodes. I could have 3 copies of that container running on the cluster. And then, of course, I could delete my cluster. Okay? As you can see, everything is hidden from you. The only thing that you have to do is create the cluster, write the compose file, which you probably have anyway because you're working with Docker locally on your PC, and just deploy it, right? So where are we? Oh, create complete. Okay, that's good news. So let's go to the ECS console here. So I see my cluster here. And probably the instance is still starting. Let's look at the EC2 console. That's the one here, okay? So that's an EC2 instance with the Amazon Linux image and Docker installed and the ECS agent, okay? So just need to start. And it should join very soon. Come on, instance. Don't let me down. But that's a good, I mean, I'm going to show you Lambda in 5 minutes, right? EC2, you see, it's not a problem of EC2. It's working with EC2. Nothing takes 1 second, right? Nothing takes 1 second. Starting an instance is always 1-2 minutes, right? And here they need to join the cluster, so it takes a little time. And well, probably that's something we can fix. Okay, here it is. Okay, so I see my instance, my EC2 instance here, right? It's running a pretty old version of Docker, but okay. I need to change my configuration, but that's okay. That's enough for what we do here. And nothing is running in here, right? So it's a 1-node cluster. Okay. So, time to deploy stuff. Oh yeah, I need to show you the compose file. Okay, so that's the compose file. Okay, so my service is called PHP demo. The image is located in ECR repository in the US. I'm opening port 80 because that's the web app. The entry point for the container is running Apache because that's the web app. And the CPU shares and mem limit, so I will explain that in detail tomorrow if you want to know. But just in 5 seconds, this is a hint that we're giving to the scheduler, to the ECS scheduler, to say this is how heavy this container is regarding CPU usage and memory usage, right? And what these points mean, as maybe you saw that here, okay? For this instance size, I've got 1024 CPU points available. So I don't have 1024 CPUs. That would be awesome, but no. It's just that I can fraction the CPU power of that instance in 1024 points. Okay, so for my PHP app, I say, hey, give it 100 points. Okay, if I wanted my PHP app to run all alone on that instance, I would give it 1024 points, and the scheduler would find an instance that is fully available for this. Okay, so it's just a way to give some hints to ECS. So, okay, let's start the service now. So what ECS does here, it's going to grab that compose file, send it to the cluster. That becomes what we call a task definition, okay? And it's going to start, since I did not give any counter, any number of services, by default, it's going to create 1 container, right? Desired count is 1, running count is 0, okay? So it's going to find an instance where it has sufficient power to start the container, and it's going to start it. Okay, so let's take a quick look at the console here. So I see my service has been defined, right? So it's going to download the image from ECR, and it's going to start it somewhere, right? See, it's pending. I've got one task pending, and pretty quickly it should be running, right? So that's it. My container has been started. Okay? So I want to see that container's running, so that's the IP address of my ECS instance. All right. That one is going to make me a double billionaire, right? I'm sure. Okay, so that's how you deploy containers. Okay, so of course, this is a bit of a silly example because I've got just one node and I've got only one container. So let's scale things. Okay, so let's add 2 more instances to the cluster. Okay, so I will have 3 nodes, and let's have 3 containers running, right? So let's continue while it's doing this, and we'll get back to that. Okay, but what I should see is 3 ECS instances and 1 container, 1 PHP app running on each, right? And all I'm saying is give me 3 nodes and give me 3 containers. You figure it out. Okay. All right, the last one, Lambda, completely different. So there's no good name for it. So people are starting to call it function as a service. So let's stick with that. And it's exactly what it means. So we saw EC2 is infrastructure as a service. ECS and Beanstalk are platform as a service, right? All the crazy stuff is created for you automatically. And Lambda, well, you only need to provide your function, not even your application, just your function. And you can do this with Java, Python, and Node.js. So we're going to look at some examples. There are 2 main use cases for this. The first one is building event-driven applications. Because as you know, within the AWS cloud, you have tons of events happening all the time. Instances starting, files being dropped in S3, items being written to DynamoDB, monitoring notifications happening, blah, blah, blah. Lots of stuff happening. And actually, Lambda is heavily used to act as a glue between all those services. So for automation, it's great. You can build complex applications by simply automating with Lambda, right? Automating stuff that is happening inside your platform. A new file is dropped in S3. Okay, run a Lambda function that takes the file, compresses it, loads its content to RDS, blah, 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 right? I call it Lego infrastructure, right? Which is a better name than function as a service. The second use case is to build APIs, right? Usually APIs are smaller pieces of code that are independent, right? Self-contained. And that fits the Lambda model pretty well. So we're going to combine Lambda function with the API gateway, which I'm going to show you, to build APIs. And this is really cool for web services, obviously. It's really cool for backends, mobile backends, people who want to build RESTful APIs without messing with any infrastructure, right? Which is the right way to do it. I mentioned that Lambda had a different pricing model. Remember EC2, you pay by the hour, right? Lambda, you only pay when the function is called, right? So it's a combination of number of requests and execution time. By 100 millisecond slots, not by the hour, of course, because Lambda functions are supposed to be very, very short. There's a 5-minute timeout on Lambda functions. So imagine you have APIs implemented with Lambda and you have no traffic at night, right? No traffic, no API calls, no Lambda calls, no money spent, right? If you used EC2 instances, you would still need to have maybe a couple of web servers to be running at night, even if there's no traffic, and you would pay by the hour. So Lambda is super efficient from a spend point of view, right? No traffic, no cost. And this is what we call serverless. I'm sure you've heard that a million times. right? The serverless architecture, that's the combination of Lambda and managed services. So let's do this. So what I'm going to do, I'm going to write a simple function. I'm going to create an API with the API gateway. I'm going to deploy it, and I'm going to invoke it with curl, right? Before we do this, let's conclude our ECS demo. So I should have 3 instances here. Yes. Okay. As you can see, right? 1, 2, 3. And I have 1. Okay. Yeah, please. Did I say 3? Yeah. Okay, so desired count for my PHP app is now 3. Running count is 1, so it's going to create 2 more. Right? So you can see 2 are pending, and really quick, they should be running. Okay? And I could connect to each specific one, or probably what I want to do is to have a load balancer in front of the 3 with a single entry point. Okay? That's what I'm going to do tomorrow. Okay? All right. Here's the second one running, and the third one will be running in a few seconds. Okay? You get the point, right? Okay, so that's my Lambda function. It's very complicated. It's in Python, okay? It receives a JSON document with 2 integers, and the function just sums the 2 integers and returns the result, okay? So let's do this. So here's my code, right? So I'm going to go to Lambda console, create a Lambda function.
So the functions are given. I'm using them. I'm a consumer of them. Is it
Yes.
correct?
Yep. So I'm going to write, yes, a blank function. I'm going to call it add. It's a Python function. Here it is. Yeah, simple role because I don't need a lot of permissions. We can leave this thing as is. Did I click it? Yeah, next. Create function. Okay, so my function is now created. So I could test it locally, but I'm sure it works. So let's add an API in front of that. So let's create a new API. Let's call it add. I'm going to create a post method. Right, so whenever I post on this API, I'm going to call a Lambda function. Which is called add.
HTTP means I could use a REST controller from
Yep. Yep. You could, sure. Yeah. Here I'm integrating the gateway of the Lambda, but as you can see, you could invoke, you could have like a public facing API calling internal APIs on your platform. Okay, so as you can see here, whenever I'm posting to that API, I'm calling that Lambda function. I could set up authorizations and tokens, etc. if I wanted to, but I don't need it today. And then all I need to do is deploy it. So I'm going to deploy to production, of course, because it works, right? Come on, gateway. And here's my endpoint. Okay? So now, what did I do? I've got a public API calling a Lambda function, so now I should call it.
With these API layer, can I also integrate services that I'm not running on AWS?
Yeah, you can call external stuff, sure. Yeah, that works. Okay, so what am I doing here? I'm using curl, posting a JSON document with value 1 of 5, value 2 7 to my endpoint. 5 plus 7, 12. Yeah? Hey, I can still speak German. All right. Okay. So again, I'm almost out of time, but keep in mind, if you had to do this with an EC2 server, would that be faster? Imagine you had to deploy all your API framework and blah, 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 blah. Could you do this in 2 minutes? Probably not. Okay. So it's time to conclude. Of course, you don't have to code in the console, right? Don't worry. You can use, there's an Eclipse plugin for Java. There's a number of frameworks that allow you to create APIs and deploy your functions pretty quickly. The most well-known is one called Serverless. It's available on GitHub. And you can automate a lot of things very quickly, very nicely. And you have other frameworks like Chalice, Zappa, Apex. If you want to do Golang, which is not supported by Lambda, you could use Apex, and they manage to run Golang code. Okay? So I'm done, well, 64 minutes. Well, that's not too bad. And now it's your time, not to explode, right? But to explore. Right? Hopefully you will not explode. There's much more to read on ECS, which I really was just an ECS flyby today. You can look up all those references. You will get the slides, don't worry. So some articles from the CTO of Amazon, some ECS videos from reInvent. There's, again, a whole lot more to learn about Lambda. Lots of videos from reInvent. And if you want to read books, I'm sure you guys like that. My colleague Danilo is writing a book on Lambda. It's almost done. You can already buy it from Manning. It's an early release. So you buy the PDF and you get the updated versions. I'm sure you've done this before. I think he only has one chapter to go, so it's really ready. I strongly recommend it. Not because he's a nice guy and he's my colleague, because it's a great book. It's the only Lambda book that you need to read. Enjoy the rest of your day. Thank you.